Now, hello guys. Today we are going to integration. Integration. Don't forget, I said earlier that calculus is divided into two. We have differential calculus and we have integral calculus. So today we are talking about integration. Now, integration is called antiderivative. You know, I said earlier that derivative means dy dx. So the anti means the reverse of dy dx, which means integration is what? Which means the reverse of what? Differentiation is what? Integration. Which means it's like the opposite, or we call it the reverse case of differentiation is what? Integration. The symbol for integration is, this symbol is for integration. Once you see this symbol, it means integration symbol. E.g., integral of x dx. Why are we writing dx? Now, the reason why we are writing integral of x dx, because for every integral, there must be the something. It can be integral of x dx, it can be integral of x dy, it can be integral of x dw. You have to integrate with respect to something. It can be with respect to x, it can be with respect to y, or anything. Now look at this, integral of 2y dy. I'm integrating with respect to y. So this symbol means integral, etc. Now, let me talk about definite and indefinite integral. Because basically we have two types of integral. We have definite and we have indefinite. Now, indefinite integral will always have arbitrary constants. C. It means for indefinite, it means not definite. For indefinite integral, there must be arbitrary constant C. There must be plus C in your final answer, because there is no, sorry, it's a mistake. There is no boundary points. There is no boundary points. It means that there is no, if I integrate now, if I put, let's say, A here and B here, that is boundary points. But if there is nothing here and here, it means it's just normal integral. So that integral, we call it indefinite. So if there is no boundary point, then we must add plus C, constant C, to our final answer. that is integral of x raised to the power of n dx. If you look at this, there is no anything here and here. So there is nothing here. This is lower bound, this is upper bound. So far there is no boundary point. So the integral of x raised to the power of n dx is an indefinite integral. Why? Because there is no boundary point. We move. Now, the next part is, but for definite integral, so definite integral has no arbitrary constant C. But for definite integral, there is no C. There is no arbitrary constant C. So why? There is boundary points. It means once there is boundary points, then there will not be what? Plus C. Once there is boundary point, there will not be plus C in your final answer. That is, if you look at this, integral of A to B of x raised to the power of n dx. This A is the lower boundary point. This B is the what? Upper boundary point. Since there is upper bound and lower bound, and we are dealing with integration, there will not be plus C. Why? Because it has the boundary point. We call it definite integral. So therefore, we can now generalize. This is the general formula for integration. We can now generalize that the integral of x raised to the power of n dx equal x raised to the power of n plus 1 over n plus 1. Then plus C, there is no boundary point. That's why we're adding plus C. Please note, what does this mean? If you observe, for integration, we are adding 1 to the power. So which means if you want to integrate a particular variable, you just add, you know this n is having power n, add plus 1 to the power. Then over that same thing you did up, you know, there is n plus 1 at the power, then there will also be n plus 1 at the bottom, which means x raised to the power of n plus 1 over n plus 1 plus constant c. Now, let's move to standard integrals, because in this we have some standard value which we call standard integral. Now, let's start from here. So, integral of sine x dx, whenever you integrate sine x is constant, it will give you minus cos x plus c, indefinite integral. There must be plus c, constant. Integral of cos x dx must be equal to sine x plus c. It is standard. Integral of sec square x dx, the answer is tan x plus c. That is the answer. It is standard. The integral of sec x tan x dx is equal to sec x plus c. It is standard. The integral of cosec square x dx is equal to minus cot x plus c. It is standard. The integral of cosec x cos x, the integral of cosec x cos x will give you minus cosec x plus c. It is standard. And the last one, and this integral of exponential of x dx, wherever you integrate exponential of x, it will give you exponential of x back plus what? Plus c. And the last one, integral of a raised to the power of x dx. If you integrate a raised to the power of x, a is a number. It can be 2, it can be 3. So if you are integrating it, it will give you a raised to the power of x over ln of a plus c. So all these, they are the standard integral. Thank you very much for watching.